In this video, we're just going to establish some of our terminology that we're going to use while we're talking about matrices for the rest of the semester. So let's just start off with the beginning. So a matrix is just an array of numbers, like the one I'm written down here. The size of a matrix is also called its dimensions, and it's described in by two numbers. So we just say the number of rows by the number of columns. So we read that symbol. It's just like a time symbol, but we read it as by. So the size of this matrix M, is got 3 rows and 4 columns. So we'd say it's a 3 by 4 matrix. Now, these guys in here are entries of the matrix M. Everything. Each one of these things is an entry of the matrix M. And the way that we describe the position of an entry, so let's describe the position, say, of 2 in matrix M. All right, so here's the 2 is right here. It's in the 3rd row and the, let's see, 2nd column. Another way of saying that is to say that 2 is the 3-2 entry of M. So always, so this is a pro tip, right? Always when we're talking about matrices, rows come before columns. So row 3, column 2. Same here. The dimensions of a matrix, you always have to have rows before columns. So the first number tells you how many rows you have. A couple of special kinds of matrices. A matrix is called square if its number of rows is equal to the number of columns. So the number of rows is equal to the number of columns. And a matrix is called diagonal if all of the entries that are not on the diagonal are 0. This right here is the diagonal. Those entries are the diagonal entries. These things over here are off diagonal entries. All right, so we say this matrix is diagonal. It's also square. So this is a square diagonal matrix. The size is 3 by 3. Okay, so we've got some words down now. Let me tell you about just a couple of special matrices. One is called the identity matrix. And the identity matrix is generally a square matrix, although sometimes people will talk about an identity matrix that's not square, that has 1s on the diagonal and 0s everywhere else. And later in this module, you'll see why it's called the identity matrix. And we would write something like, so I would write I sub 3 for this. So this is I for identity, the identity matrix. And the 3 tells you what the size is. So this is I 3 by 3 because the size of this matrix is 3 by 3. Or sorry, it's I 3 because this is a 3 by 3 matrix. It's got 1s on the diagonal and 0s everywhere else. I2 would look like this, and IN in general is going to look like, you get the idea. All right, so that's the identity matrix. That's a special matrix. Another special matrix that comes up once in a while is the 0 matrix. That has a good name because it tells you exactly what all the entries are. The 0 matrix is just a matrix with all 0s in it. And 0 matrices don't have to be square. So this is a 2 by 3, size 2 by 3, 0 matrix. Okay, so I think that's where I'm going to stop with the jargon. That's all we need for the moment. In the next video, we'll start talking about actual vector operations, or sorry, matrix operations.